Okay, hello folks. This is the first of our SUVAT questions, exam questions I'm going to go over with you. Okay, you should have it on your sheet as well. So we've got an OCR question here from June 2009. Object projecting vertically upwards with speed 7 meters per second. Calculate, first of all, the speed of the object when it is 2.1 meters above the point of projection. So, first of all, the speed of the object. It's an interesting one. That's obviously scalar, not a vector value. So if we just put number 1 here, what do we know? Well, the initial speed going upwards, which it tells us vertically upwards, is 7. So I'm going to measure all of my values taken from this upward projection. So if I u equals 7, that is 7 going upwards, if that makes sense, as a velocity. So the thing's obviously going to be slowing down because there's acceleration and gravity acting against it. So we take our acceleration throughout this as minus 9.8. We'll do 9.8 meters per second squared. Okay, it could be minus 10, minus 9.81, whatever it is, but we're going to take it as minus 9.8. We're looking for a total displacement of 2.1, so it's 2.1 meters above where it started, s equals 2.1. All we're then doing is looking at this and saying find the velocity of it at this point, so try and find v. We can now see we've got v, u, a and s. So if we choose to use v squared equals u squared plus 2as as our formula that we're going to put in, so we're going to have 7 squared plus 2 lots of minus 9.8 times by 2.1. If we type all that into a calculator here, we're going to have 7 squared, which is 49, plus 2 times minus 9.8 times 2.1, altogether, bang, comes out 7.84. All you need to remember then to do is square root. So therefore, the velocity, if we square root that, square root answer, it gives us 2.8. So we can see that the actual speed of the object at that point is 2.8 meters per second going upwards. Okay, on to the second one now. If we look at part 2, the greatest height above the point of projection reached by the object. Well, again, thinking about this thing being fired up in the air with a speed of 7 meters per second, we know what the acceleration is, minus 9.8, that's my default. This point, we're looking for the greatest height, and so when will that happen? Well, that's the point when it actually stops moving in the vertical plane, and so the actual velocity of it in the vertical plane, v, is going to be 0. So we're basically saying, how long does it take, or so in distance-wise, to get from 7 going upwards to 0? So we need to work out s. So again, v, u, a and s, we can use the same formula we did before, v squared equals u squared plus 2as. Substitute our values in there, so we've got 0 squared equals 7 squared plus 2 lots of minus 9.8 times, I don't know, which is the s. So 0 is equal to 49. We've got minus 9.8 times 2, which is minus 19.6 s. So 19.6 s is 49. If we just divide 49 by the 19.6, that gives us 2.5. And so we know that it's 2.5 meters above where it started. Okay, and then the third question, the time after projection when the object is traveling downwards with a speed of 5.7 meters per second. So traveling downwards rather than going upwards at 5.7, coming downwards at 5.7. So remember, it's all symmetrical when we're firing these things up. So in this case, going upwards initially, we still know u is 7. What we're looking for now is the velocity, what's going on when the speed is 5.7 coming downwards, so v will equal minus 5.7. We're looking to work out t, and of course we know a is still minus 9.8, that's never going to change. So this time we've got v, u, a and t, we'll choose to use v equals u plus at, so minus 5.7 is equal to 7, plus minus 9.8 lots of t. So just quickly jiggling around that, if I move the 9.8t to the left-hand side, I add the 5.7 on there, goes to 12.7. So t is going to be 12.7 divided by 9.8, and that will give me 1.295 or whatever it is, so 1.296, okay, seconds. So that will be how long afterwards that we've got that it is at this point. Okay, so that's how long after projection it will be coming back down at 5.7 meters per second. Okay, there'll be another question on soon. Thank you.